Hello, this is Britt Caswell with another example video. In this example, it is in section 1-6 in the SavvasRealize Algebra 2 textbook. This is example number 2, solving a system of linear inequalities. This example I feel like is a little bit backwards, so I'm actually going to solve it backwards because I don't like that it goes into a word problem right away and then gives you just the basic set of graphing. So let's start by making sure that we know how to graph a system of linear inequalities, and then I'm going to go back up and we're going to do the word problem together. So let's take a look. So we have 4 inequalities that I want to put on the same graph, okay? And what we are looking for is we are looking for any points that satisfy all 4 of these, okay? So what I'm going to do is I'm going to go through and graph each of these just one at a time. And then by the end of it, I'm going to be able to kind of have like a range of values, okay? So my first inequality says 2x plus y is less than or equal to 14. Alright, I can either put it in slope-intercept form, you know, the y equals mx plus b, and graph it that way. Or I can actually graph it this way in standard form. What I'm going to do is I'm actually going to try to find the intercepts right away. So first, I'm going to figure out what happens when I plug in a 0 for x. Okay, that'll give me some point on my y-axis. And then I'm going to go through and plug in a 0 for y. And that'll give me a point here on the x-axis. I find that that's a little easier for me than doing the slope-intercept form, but either way works, okay? So if I plug in a 0 for x, this inequality turns into 2 times 0 plus y is less than or equal to 14. Now 2 times 0, that's just 0. So this whole term goes away, and I get that y is less than or equal to 14. So that 14 is the point that I'm going to put right there. So if I'm on here, okay, I'm going to put a little note here that my boxes are counting by 2's. Okay, that's called the scale, just a reminder. So I'm going to go to that point, 0, 14 on my graph. So here we are. So 0 on the x-axis will be somewhere on the y. And then I have 2, 4, 6, 8, 10, 12, 14. So that is this point right here. So in order to draw a line, I need a second point. So now I'm going to go through and I'm going to do the same equation, but where the y is, I'm going to plug in a 0. So I have 2x plus y, which is 0, is less than or equal to 14. So the term with the 0 falls out because adding 0 does nothing. So that gives me 2x is less than or equal to 14. Now remember, when you have a number and a letter squished together, that's a multiplication problem. So to undo my multiplication, I'm going to divide by 2 on both sides. So I get that x is less than or equal to 14 divided by 2 is 7. So my second point that I'm looking at is at 7, 0. Now remember, my scale is counting by 2's. So I have 2, 4, 6, and then to get to 7, I'm looking at the halfway marker right here. Alrighty, so now that we have those 2 points, we're going to draw a line between them. Now there's 2 kinds of lines that we have, okay? We can use a solid line or a dotted line. So if I use a solid line, it can be equal to. Okay, so that means that on the inequality, it has the little bar under it, like you see there. If I use the dotted line, it cannot be equal to it. So that's saying that it would have a symbol like less than or greater than, but doesn't have the bar under it. Alright, so if I'm looking at my set of inequalities that I'm given, all of these have bars under them, so I'm going to be using a solid line on all of them. But just be aware, sometimes they'll not have the bar, and then you want to use a dotted line, okay? So I'm going to try to connect these with as straight of a line as possible. And as you get to know Miss C really struggles with straight lines. That one's almost good. It curves a little bit, but you get the general picture. And then we have to talk about shading. So inequalities, when they have two variables, like x and y, they tend to shade the side of the line where all the solution sets are. Alright, so just like when we were dealing with a number line, we'd shade to the left or right. Now that we're on a coordinate plane, we're also going to shade to the left or to the right. So what I tend to do is I tend to pick an anchor point that is not on the line. Okay, that's important. It can be to the left of the line, it can be to the right of the line, but you don't want one that is on the line. Okay? I'm actually going to be picking 0, 0. So let me go ahead and let me erase some of this extra work. And now we're going to test to see if 0, 0 is a solution. So if I plug in 0, 0 and it works, if I get a true statement, I'm going to shade towards that point. But if I plug it in and it doesn't work, then I'll make sure to shade away from it, if that makes sense. So here we go. So 0, 0 is right here. It's the origin, right? So that's saying I plug in a 0 for the x. So I get 2 times 0 plus, and I'm plugging in a 0 for the y. So plus 0 is less than or equal to 14. Well, 2 times 0 is 0, right? And so any term that is 0 plus something, the 0 doesn't matter anymore. My second term is also a 0. So this entire side of the inequality is just 0 is less than or equal to 14. And we have to ask ourselves, is that true? Well, yeah, it sure is, isn't it? 0 is a smaller number than 14. So that means at this point, 0, 0 is a part of the solution set. So I would take my colored pencils. Sorry, I don't have like a shading tool on this app. And I would shade everything here towards 0, 0 from the line. Okay? So my solution set for this blue one is my line, which we're going to pretend is straight, and then everything to the left of that line. Alrighty, so now let's try this kind of orangish one. Okay? Now with the orange one, I'm going to do the same process, and I'm going to graph it on the same graph as the blue one. Okay? So what we're trying to do is figure out where all these things are going to overlap, and so you want to make sure that you're graphing it on the same graph so that you can compare them. Okay, so I am working with x, oops, not less than. So I'm working with x plus 2y is less than or equal to 10. And I'm going to find the two intercepts. So I'm going to plug in a 0 for x to figure out where it intercepts the y-axis. And then I'm going to plug in a 0 for y to figure out where it intersects the x-axis. So here, where x is, I'm going to replace it with a 0. So I get 0 plus 2y is less than or equal to 10. So adding 0 to anything doesn't matter. So I get 2y is less than or equal to 10. And this is 2 times y, so I'm going to divide by 2. I'm going to get y is less than or equal to 10 divided by 2 is 5. So my first intercept on the y-axis is at 0, 5. So 2, 4, 5. That's right here. Okay, so now I'm going to do the same thing, but I'm going to figure it out on the x-axis. So I'm going to plug in a 0 for y, so I get x plus 2y, remember y is 0, is less than or equal to 10. So 2 times 0 is 0, so that term can go away. So that leaves me with x is less than or equal to 10. So there's my second point. So I'm going to go 2, 4, 6, 8, 10. That's right here. And then remember we were looking to see if we use a solid or a dotted line. Because there's the equal to bar under the inequality, I'm going to use the solid line to connect these. I'm going to try to do it with as straight of a line as possible. Now y'all kids using the Savvas textbook, they have graphing technology in here to help you. Desmos.com will also help you, okay? It'll get you those nice crisp lines. You know, graphing by hand, there's a little bit of error and you know, I have a slight curve, or you know, I'm between points here. So I recommend using a graphing software here to help you check and make sure you're doing it right, okay? So now we've drawn our line. So now we need to figure out with this inequality which way to shade it. Okay, so remember you're going to pick a test point and you're going to plug it in and see if it works. And again, that test point cannot be on the line that I'm choosing. So in general, I usually prefer 0, 0 because it's such an easy number. Zeros are easy for me. And if I look, 0, 0 is not on the line, right? 0, 0 is the origin. So that's the point I'm going to plug in to check. So where x is, I'm going to replace it with a 0. Where y is, I'm going to replace it with a 0. Now 2 times 0 is 0. So 0 plus 0 is 0, is less than or equal to 10. And then I have to ask myself, is 0 less than or equal to 10? Well, it is. So when I go to shade this orange line, I would shade in the direction of that 0, 0. So I'm going to use this to make some little hashtags. If you guys are writing these notes on paper, colored pencils are super helpful here. Just make sure you're using light colors. Okay, so it shades down. So right now, the current solution set between those 2 points that I have so far is like this point right, or this little quadrilateral that's right here, because that's where it's overlapped so far, as well as all this stuff. Okay, so we're going to try to narrow this down, okay, to not just this little quadrilateral, but we have this stuff that's out here. Notice here, see how there's orange but there's not blue? So this wedge where there's coloring but there's not coloring of all the colors, that's not the answer. The same thing is up here. This wedge with just the blue is not the answer. It's where they're both overlapping. Alrighty, so now let's check out our next one. These ones that have the single variable, they tend to be a little bit easier. Alrighty. So for this green one, it says x is greater than or equal to 0. So that's talking about the positive x-axis. So if I were to graph the line x equals 0, that is a vertical line that's right here on the y-axis. It's this line right here. And I'm using a solid line because it can be equal to. Now in terms of shading, I'm looking for x is greater than that 0, or equal to it. So I'm going to shade where all the numbers are greater than 0 on the x-axis. And that's going to be here to the right. So in terms of my inequality, now I've kind of cut down my solution set, right? Now I'm looking at this area right here. So let's check out the purple one and see what else that does. This is the closest purple I've got, I think. So this one says y equals 0. So if I have a line that says y equals 0, okay, that's going to be a horizontal line, which is right here on the x-axis. Okay, I used a solid line because it can be equal to right here. And so for all the y values greater than 0, I'm going to go ahead and shade up because that's above the axis. Now you can see these lines get a little overwhelming, don't they? Especially if I don't have like a shade tool. So what I want to do to help you guys see it is I'm going to go through in black and I'm going to look at these boundaries real quick. Okay? So the overlapping we know is to the right of the y-axis. So I'm going to put some black here so we can see that. We know that it's above the x-axis. That's what we just shaded in the purple. So I'm going to draw part of it above there. The next part was this blue line, right? And it was everything to the left of the blue line. Okay, which is right there. And then it's everything below this orange line. So we have kind of this shape going on for our overlap. So to make things more clear, I'm gonna erase all this extra stuff just so that we can see the boundaries of this black shape a little easier. Because by now all my little markers are gone, okay? I can't see these tick marks very easily. Now you guys can't really do that so well on paper, right? You can't just erase your whole graph. So make sure if you're using colored pencils or pens that you're using something that you can kind of see through, okay? So here's our general shape. So I can pick as a solution set any point that's in here, okay? Everything that's in this boundary is a solution. All right, so this point right here, that's 1, 1. That could be a solution. This point, or I'm sorry, that's not 1, 1, is it? Because I counted by 2s. That one's 2, 2. Now 1, 1 would be right here, and that's also a solution, right? I could pick this corner, this vertex for my weird little quadrilateral, which is at 7, 0. That would work because it's in that boundary. Okay, so there's a ton of points I could pick from here, right? So I could pick 4, 2, which is that point right there. That's also a solution. So anything that's in there or on the border of this is part of the answer. Right? Now this has been kind of a long video, so I'm going to cover the word problem in a second video. Alright? But until next time.